Hi and welcome to this video on integration and in particular indefinite integration. So if we have a function such as x to the power 4 plus 4x minus 5 and we get the derivative, it's 4x to the power 3 plus 4. Now what if we wanted to find a function that when we get the derivative of it we get back to the original function? So that's what integration is about. It's finding the antiderivative. So if we just think about it a little bit, if we have f of x equals 1/5 x to the 5 plus 4 over 2 x squared minus 5x. If we differentiate that, we get x to the power 4 plus 4x minus 5. Now the problem arises that if we also had 1 over 5 plus x 5 plus 4 over 2 x squared minus 5x plus 10, and we differentiated that, now this is a constant, we'd still get this function. Or if we had plus 6, we'd still get this function. So when we differentiate, when we sort of anti-differentiate or integrate, what we get is a general function. We need some more information to find out the constant. Let's have a look at how we write out integration. So in general form, the integral, that's the integral sign, or f of x dx, the dx is important, equals f of x plus c, and the c is important. So this is the integral sign, f of x is the integrand, x is the integration variable, and c is called the constant of integration. So when we write out the integration, we usually write the integration symbol followed by what we're integrating, x4 plus 4x minus 5 dx, and then we write equals 1/5 x to the 5 plus 4 over 2 x squared minus 5x plus c. We look at the integral sign and the dx as a set of parentheses, and we're integrating whatever's in between, and then we find out what the integral is, and then we end with plus c. So this would be the function we're integrating. Dx is important. It signifies are integrating with respect to. So we always need to write the dx as it tells us in this case that we're integrating rather with respect to x. So let's have a look at an example. So if we have integrate 2x dx, we'll get x squared plus c. So this means only integrate x in the integral and all others are constants. So if we have integrate 2t dx, we get 2tx plus c. So we had a look at this earlier. This is the integral. This is a constant of integration. And this is an indefinite integral. And we're differentiating, rather integrating, with respect to x. Now let's have a look at some basic integration rules that we need to memorize. So the integral of 1 dx equals x plus c. The integral of x to the power r equals x r plus 1 over r plus 1 plus c. The integral of cos x, so I missed the dx there, we're integrating with respect to x, equals sine x plus c. The integral of sine x dx equals minus cos x plus c. This one can be confusing, but because if we remember when we differentiate cos x, we get minus sine x. But in this case, we're integrating sine x, so the opposite way is we reverse the signs. So when we're going to operate the antiderivative, or the integral of sine x is minus cos x. If we have sec squared x dx, the integral is tan x plus c. The integral of cosec squared x dx is minus cotangent x plus c. Let's carry on over here. The integral of sec x tan x dx is sec x plus c, and the integral of cosec x cot x dx equals minus cosec x plus c. So those are the basic indefinite integrals that you need to know. Let's have a look at just some others which come up quite often. So the integral of e to the x dx equals e to the x plus c. The integral of a to the x dx equals a to the x over natural log of a plus c, and the integral of 1 over x dx equals square root of x to the minus 1 natural log of x plus c. As well as these, sometimes you get some trig. So let's have a look at that. So if we ever get the integral of 1 over x plus 1 dx, this equals tan to the minus 1 x plus c, and if we get the integral of 1 over square root of 1 minus x squared dx, it equals inverse sine x plus c. So those are to be memorized and coming very useful when we're doing indefinite integration. Integration rules and doing some examples of integration. So integrating a variable raised to a power. So if we have the integral of x to the power n dx, the way we integrate it is, the rule is x to the n plus 1 over n plus 1 plus c. So if we have an example, if we have the integral of x cubed dx, we have x, raise the power by 1, 4, and bring the 4 down, plus c. Example, if we have the integral of y to the power pi dy, this equals y pi plus 1 over pi plus 1 plus c. If we have the integral of z to the minus 5 dz, this equals z minus 5 plus 1 all over minus 5 plus 1. So minus 5 plus 1, that equals z to the minus 4, and minus 4 on the bottom. And don't forget the plus c. If we rearrange that, we get minus 1/4 plus 1 over z to the power 4, which equals minus 1 4 z to the power 4 plus c. When we're integrating a polynomial, we can write it as two polynomials. For example, 3x cubed plus 4x squared have the integral of 3x cubed dx plus the integral of 4x squared dx. And when we do that, we take the constant to the outside, integral of x cubed dx plus 4 integral of 4x squared dx, and that equals 3x to the power 4 over 4 plus 4x cubed over 3 plus c. Similarly, if we have this, which is a minus sign in there, let's have a look. So this would equal minus 2 integral x squared plus 4 integral of x minus 3 integral dx, and this would equal minus 2x cubed over 3 plus 4 x squared over 2 minus 3x plus c. As we did at the top here, we moved the constant to the outside, and let's just have a look at some examples of that integration of a constant. So if we had integral of a to the x, we can move the a to the outside and have dx, and by dx, by definition, dx equals x plus c. So the integral of a dx equals a dx, which equals a x plus c ax plus ac, and that's ax plus c. So the integral of a dx is ax plus c. Where we have nothing here, we take that to be a 1, and then when we integrate the 1, that becomes the x. So if we want to do really quick about it, so a, when we integrate it, dx, we get x, bring the a back over, ax plus c. Similarly, if we have the integral of minus pi dy, we get minus pi integral of dy, and that equals minus pi y plus c. Okay, when we are integrating fractional and root types of functions, what we try and do is make them into our standard form of function that we know how to integrate. So that would be ax to the n dx. We apply our rule then, which is ax to the n plus 1 over n plus 1 plus c. So let's have a look at this first one, integrating 4 over x squared dx. So this equals the integral of 4x to the minus 2 dx. Integral of 4x to the minus 2 dx. And when we apply our rule, we get 4x to the minus 1 over minus 1 plus c. Rearranging that, it's minus 4x plus c. In this case our constant is 5 over 4, so we take the 5 over 4 outside the integral sign, and then we have x to the minus 3 over 2, no, 2 over 3, minus 2 over 3. It's to the third root, x squared, 1 over, means the minus stands for 1 over, so it's x minus 2 over 3. And when we integrate that, we get 15x to the 1/3 over 4 plus c. We had a look at the constant rule earlier. When we have a constant and then the function, we can take the constant outside, do the integration, and then bring the constant back and multiply. Where we have two functions plus or minus each other, then we can get the two, split it into two, and we can get the integrals and add or minus them together. Where we have two functions multiplied, there is no product rule in integration. So this does not equal that. Let's have a look at some quick examples. So integral of 2 dx, bring the 2 out, integral of x, this equals 2x squared over 2 plus c. The 2's cancel each other out, and that equals x squared plus c. 1 plus x dx, where we have a 1, we can split this into 2, so the integral of 1 dx and the integral of x dx. So this then becomes, the integral of 1 is x, and the integral of 1 is x, and the integral of x is x squared over 2 plus c. Where we have x plus x squared in parentheses, we can ignore the parentheses. And this simply, again, split the two functions, becomes x squared over 2 plus x cubed over 3 plus c. Where we have the brackets, whatever's in the brackets, squared. Now how do we do this? Well, we can FOIL. Quick look at exponential types and integration of exponentials. If we have y equals x squared and we differentiate dy by dx, we get e to the x. When we integrate e to the x, we get e to the x plus c. If we have a constant before the e to the x, say we have y equals a e to the x, when we differentiate we get dy by dx equals a e to the x. And when we integrate we get a e to the x plus c. So these are the rules for the integration. When we have a e to the ax plus b and we integrate, there's a slight difference, so we'll go through that. So if we have y equals e to the ax plus b, when we differentiate dy by dx, we get a e to the ax plus b. However, when we integrate, we have this, which is a times 1 over little a. So it's the constant over 1 over little a, which is there in the power. And then this b is not involved. And the integration goes 1 over a, or a times, or multiplied by 1 over a, e ax plus b. Okay, let's go over some quick examples. If we have integrate 3 over 5 e to the 2x, this becomes bring the constant to the front, then integrate e to the 2x dx, and this becomes 3 over 5. Remember, the 1 over the a becomes 1 over 2, e to the 2x plus c, which equals 3 over 10, e to the 2x plus c. Another example, if we have 2 over 3 e to the 3x minus 2 dx, so there should be a dx there, equals bring the constant to the front, integrate e 3x minus 2 dx, becomes 2/3, 1 over 3 e to the 3x minus 2 plus c. And then we'll tally that up, 2 over 9 e to the 3x minus 2 plus c. So that is your answer. That was the answer. Right. Let's have a look at another one. So if we have 4 over 3 e to the 5x dx, bring the constant to the front, then integrate e to the minus 5x. Remember, if it's on the bottom of a fraction and we want to take it up, we put a minus. This becomes 4/3 multiplied by minus 1 over 5 e to the minus 5x plus c, and when we tidy that up it becomes minus 4 over 15 e to the minus 5x plus c. If we want to combine the e with the minus 4 and 15, because of the minus sign, leave the minus 4 on the top. Remember, the minus goes on the bottom of the fraction, so it's 15 e to the 5x plus c. And that is our answer. Integral of 3 e to the 7x minus 2/3 e to the 5x minus 1 dx. So what can we do here? Well, we can, because if there's a minus sign or a plus sign, we can split this into two integrals. So we have 3 integral of e to the 7x minus, bring the constant to the front, e 5x minus 1 dx. Now this one becomes 3 over 7 e to the 7x minus, so it's 2/3 times 1/5, which is 2 over 15 e to the 5x minus 1 plus c. And that is our answer. Functions now, if we have something in the integrand which looks like ax plus b to the power n, we can often integrate this by recognition that it came from ax plus b to some power, and then we differentiated to get back to the original function. So if we have something like the integral of 5x plus 2 to the power 4 dx, if we think back to our chain rule, we would have to differentiate rather, something like 5, 6 plus 2 to the power 5 to get back to 5x plus 2 to the power 4. Now when we differentiate, we bring the power down, and we multiply by the a that's in the bracket, so that would be the 5. So that would be 5 there. So when we differentiate this, we get 25 5x plus 2 to the power 4. Now we don't have a 25 here in this integrand, so how do we get rid of the 25? We multiply by 1 over 25 times 25, 5x plus 2 to the power 4. So this then becomes 1 over 25 5x plus 2 to the power 5 plus c. Okay, let's have a look at another example. If we had the integral of 8 5x minus 1 minus 3 dx, this becomes the integral of 8 outside the integral sign, 5x minus 1 minus 3 dx. So this looks like this function, and we can possibly do it by recognition. So let's turn our thoughts back to the chain rule. What would we have to differentiate to get back to this original function? Well, we'd have to differentiate something like 5x to the minus 1 to the minus 2. When we differentiate minus 2, we get minus 3. Remember, it's nx to the n minus 1 is the rule for differentiation. So minus 2 minus 1 is minus 3. So that would take us back to the original integrand. Now remember, in the chain rule what we do is we bring the minus 2 down, then we have the 5x minus 1, then the minus 2, and then we multiply by 5. So this would give us 5 times minus 2, which is minus 10, 5x minus 1 minus 2. When we differentiated, we would get that. So we don't want the minus 10, we want the 8. So what do we have to do? So we have to divide by minus 1 over 10. And that will get us back to this function. So this then becomes 8 over 10 5x minus 1 squared plus c, and that is our answer. So we bring the 8 over here and multiply by minus 1 over 10. Okay, looking at another example, if we have 4 integral of 7x minus 3 to the half dx. So what do we differentiate to get back to this? So it would be something like 7x minus 3 and then to the power 3 over 2. So if we differentiate that, we should get back to the power half. Remember that the 3 over 2, when we differentiate, comes to this side, and then we multiply by 7 in the chain rule. Here we don't have anything, so we want to get rid of the 7 by 32. So what do? We divide by 7 times 3 over 2, which is 21 over 2. So this then becomes 4 divided by 21 over 2, 7x minus 3 to the power 3 over 2 plus c. And then when we tidy that up, 4, 21 is 8 over 21. And power 3 over 2 means it's the square root of 7x minus 3 all to the power 3 plus c. And that is our answer. Rules of integration quite quickly revised. So if we have the integral of 6t cubed minus 10t to the minus 6 plus 4 dt, we can split this into parts. So we have 6 integral of t cubed minus 10 integral of t to the minus 6 plus integral of 4 dt. Quickly going ahead, we have 6, 3 plus 1 is 4, so that'll be 1 over 4. t to the 4 minus 10 multiplied by minus 6 minus 1 plus 1 minus 5, so that's multiplied by minus 1/5 t to the minus 5 plus 4t plus c. And when we tidy that up, we get 6 over 4 t to the 4 plus 2t to the minus 5 plus 4t plus c. And that is our answer. Okay, integral of x to the 7 plus x to the minus 8 dx. So this then becomes integral, when we integrate 7 plus 1 is 8, so that becomes x over 8 over 8 plus minus 8 plus 1 is minus 7 over minus 7 plus c. When we tidy that up, we get 1 over 8 x to the 8 minus 1 over 7 x to the minus 7 plus c. And that is our answer. Integral of root 4 x to the power 3 plus 7 over x to the power 5 plus 1 over 5 root x dx. So first of all, what we have to do is make these integrals fit the integration table. So we have the integral of x power 3 and 4, so that goes, the 4 goes on the bottom and the 3 goes on the top, plus 7x, when the 5 is underneath the fraction it becomes a minus 5, plus integral of 1 over 5 to, so that becomes 1 over 5 x square root half, and then because it's underneath fraction becomes minus a half dx. Now we can go further, take the constants outside, so that becomes integral of x to the 3/4 plus 7 x to the minus 5 plus 1/5 over x to the minus half dx. Now when 3/4 plus 1, so that's 4 over 4, becomes 7 over 4, so that's x 7 over 4 over 7 over 4 plus 7 x minus 5 plus 1 is minus 4 over minus 4 plus 1/5 x minus a half plus 1 is a half and over a half plus c. And when we tidy this up we get 4 over 7x to the 7 over 4 plus minus 7 over 4 x to the minus 4 plus, bring the half up to the top 2 over 5 x to the half plus c, and that is our answer. Just a quick aside, if we have the integral of dy, this equals the integral of 1 dy equals y plus c. Integral of k dx, we're integrating with respect to x, and there is no x there, so we treat everything as a constant, so this equals kx plus c. Integral of w plus the cube root of w and then brackets 4 minus w squared, and that's dw. So how would we do that? Well, we've got two things in brackets. We need to get rid of the brackets so we can multiply out, and that will give us 4w minus w cubed plus 4w to the minus 1/3 minus w to the 7 over 3 dw. And when we integrate, we get, that becomes 2w squared minus 1/4 w to the power 4 plus 3w to the 4/3 minus 3 over 10 w to the 10 over 3 plus c. And that is our answer. When we have an integral over just one term in the denominator, like 8x to the 10 minus 2x to the power 4 plus 15x squared all over x cubed. So here only one term. That's quite important. We can split this into different fractions. So this will become 8x to the power 10 over x cubed minus 2x to the power 4 x cubed plus 15x squared over x cubed dx. When we tidy this up, we get the integral of 8x to the 7 minus 2x plus 15x to the minus 1 dx. And all these integrals can be separated. So doing now the integration, let's take the constants out first. So 8 integral of x to the power 7 minus 2 integral of x plus 15 integral of x minus 1. Integral of x minus 1 is 1 over, no, it's not 1 over x over 1 is 1 over x, and that equals the natural log of x plus c. So here when we do this becomes x over 8, x 8 to the power 8 over 8, so this then becomes x to the 8 minus x squared plus 15 natural log x plus c. And that is our answer. Integral of 4e to the x plus 5 cos x minus 10 sec squared x dx. Again, we can do these separately. So this becomes, when we integrate 4e to the x, e to the x, 5 cos x, the integral of cos x is sin x, so that becomes 5 sin x minus 10 sec squared x, so that becomes 10. Sec squared x is, the integral of sec squared x is tan x plus c. You have the integral of 2 sec w tan w plus 1 over 6 w dw. So we can split this into two, so we have the integral of 2 sec w tan w plus the integral of 1 over 6 w dw. The integral of sec w tan w is 2 sec w plus 1/6 is the constant, and we're left with 1 over w, and when we integrate 1 over w, we get the natural log of w plus c. And that is our answer. The integral of cos x over sine squared x dx. We can split this again. We have sine squared x is sine x, so this becomes the integral of 1 over sine x, which is one of those taken care of, multiplied by cos x over sine x dx. One over sine x is cosec, that is cosec x cot x, and when we integrate that we get minus cosec x plus c, and that is our answer.